what I'm going to teach you is something which is of practical importance in straight lines, which is transformation of coordinate axis. In the sense, suppose this is small x, small y. Coordinate system, small x, small y. And this is an origin O. Small x, small y, and this is an origin O. Right? Now, I shift the origin. I shift the origin. I shift the origin to a point, say, h comma k. This is the new origin, say. H comma k are the coordinates of this new origin with respect to small x, small y, right? Origin shifted to h comma k. So I've shifted the origin, shift of origin. No. Maintaining the axis parallel. Now the new coordinate axis, let's say, capital X and capital Y. Capital X and capital Y are the new x and the y axis. This is the new origin. The position of the new origin referred to this is h comma k are the coordinates of the new origin. Say this is the old axis and this is the new axis. And I want to migrate from the old axis, that means small x, small y, to capital X, capital Y. I want to migrate from small x, small y. The position of a point referred to the old axis is small x, small y. And the position of the same point measured to the new axis is, say, capital X, capital Y. This is the transformation that I am seeking to perform. Now, say there is a point P. Anywhere. There is a point P anywhere. And its coordinates referred to the old axis. Referred to the old axis are small x, small y. Coordinates of P referred to this reference axis. Small x, small y. Now I want to find the relationship that will connect small x with capital X and small y with capital Y. Now that's very easy because, see, do you realize that this length is capital X? This length is capital X. If this is the new origin, then the x coordinate of the point capital X, the x coordinate of the point P referred to the new axis is capital X. This is capital X. Yes or no? X coordinate referred to the new axis, right? And this length would be capital Y. Yes or no? Right? Now, do you also realize that this length is small x? Do you realize that? This would be the x coordinate of the point P referred to the old axis, referred to the old axis. Do you then notice that small x and this length is h? This length is h units. Do you then realize that small x is capital X plus h? Small x would be is h plus capital X plus small h, right? So the x coordinate referred to the new axis, referred to the old axis. X coordinate referred to the old axis is going to be x coordinate referred to the new axis plus h, where h is the x coordinate of the new origin. X coordinate of the new origin. The origin has been shifted to h comma k, right? Now, similarly, this length is going to be k. The y coordinate of this point, right, is going to be k. Yes or no? Right? This is going to be the y coordinate of P in the old axis. This is going to be the y coordinate of P in the old axis, that is small y, right? Small y is capital Y plus k. Yes or no? So then small x turns out to be capital X plus h, small y turns out to be capital Y plus k. This is the transformation. That means if there is a point small x small y in the old system, say is 2 comma minus 1, right? And the origin is shifted to hk, which is 1 comma 3, say the origin is shifted to 1 comma 3. Then if you have to find the coordinates in the new system, capital X would be small x minus h, small x is 2 minus 1, which is 1, and capital Y would be small y minus k, small y, which is minus 1 minus k is 3, so minus 4. So the coordinates in the new coordinate axis, whose origin is hk, is going to be this. Now, the objective is a little different. You understand this transformation, how to go from small xy to capital XY. Small xy are the coordinates of the point P in the old system. Capital XY are the coordinates in the new axis, and hk is the position of the new origin referred to the old axis. Right? Now, suppose there is a straight line whose equation in the old axis, there is a straight line in the old system, its equation is 2x plus y minus 1 equal to 0. Is the equation of a straight line referred to small x, small y, referred to the old system, right? Now, the origin is shifted. Say the origin is shifted to 1 comma 2, hk. Origin is shifted to 1 comma 2. I now want to be able to find the equation of the straight line in the new coordinate system, right? Now in the new coordinate system, I want to find the equation of the line in capital X, capital Y system, in the capital X, capital Y system, right? Now small x is capital X plus h. H in this case is 1. Small y of the old system, y coordinate in the old system, is y coordinate in the new system plus k, which is 2, right? I want to find the equation of this line in capital X, capital Y system, in capital X, capital Y system. Equation of this line is what? 2x plus y minus 1 equal to 0 is the equation of this line. Let me replace small x by capital X plus 1. Small y by capital Y plus 2. Minus 1 equal to 0. Yes or no? Which then gives me like a 2x plus y plus 4 minus 1, 3 equal to 0. This is the equation of the line in the new system. This is the equation of the line in the new system. Right? Is that all right? In the capital X, capital Y system. Now what you do is, once you've migrated from the old system to the new system, once you've migrated from the old system to the new system, that is from small xy to capital X, capital Y, take a practical approach. Call the new capital X, new capital Y as small x, small y. You know what I'm saying? What you do is, why do you need small xy and capital XY together? This is the equation of the line in the new system. This is the equation of the line in the new system. Call the new system as some small x and small y. Then the equation of the line in the new system would be, otherwise you would always have to write one big capital X and one big capital Y and so on and so forth. So now if you now choose to call this as small x and this as small y, This will be 2 times small x plus small y plus 3 equal to 0, equation of the line in the new system. Or if you don't like this, follow this. Have you understood this? How to go from small xy to capital XY, the migration from small xy to capital XY. Small x is capital X plus h, small y is capital Y plus k, and then replace small x by capital X plus h, small y by capital Y plus k, where hk is the position of the new origin referred to the old origin. Right? This is shift of origin. This is shift of origin, but maintaining the x and y axis parallel. This is shift of origin, but maintaining the x and y axis parallel. Now what I do is I maintain the origin, but let me rotate the axis. Let me maintain the origin, but rotate the axis by an angle theta. Okay, that will be my new system of coordinates. Is that all right? Say small x, small y. This is the origin O. This is the origin O. I create a new set of axes. This is, say, capital X, capital Y, without tinkering with the origin, This is rotation of axis, and let's say the axes have been rotated by an angle theta. The angle between the old x-axis and the new x-axis is going to be theta. So the angle between the old y-axis and the new y-axis will also be theta. That will be maintained. Clear? Yes or no? So now, from small x, small y, I want to be able to migrate to capital X, capital Y. This is the new system. This is the old system of measurement. Right? Now, suppose there is a point P. There is a point P located somewhere with coordinates small x comma small y. With coordinates small x comma small y. I want to go from small x small y measurement in the old system to measurement in the new system. I want to migrate from small x small y to capital X capital Y. Right? Have I confused you? No? Then shall I try? No. Okay. See, let me project P onto this point. Say Q. And then I draw this perpendicular to the new y-axis, new x-axis. Perpendicular to the new x-axis means parallel to the new y-axis. This is parallel to the new y-axis. This is theta. This is 90 minus theta. Right? 90 minus theta, 90 minus theta. This is 90 degrees. So this will be theta. Yes or no? Yes or no? Right? What is PS? Can I say it's capital Y for the point P? PS, can I say it's capital Y for the point P? Distance from capital X This will be capital Y parallel to this, right? So PS would be capital Y. For the point P, can I say OS is capital X? Right? PS is capital Y. OS is capital X. What is this length? If this is Y, do you realize this is Y cos theta? If this is Y, this will be Y cos theta. Y cos theta, right? This length is going to be Y cos theta, right? Capital Y cos theta. What is this? This length is capital X, X coordinate in the new system, capital X. This will be capital X sin theta. This will be capital X sin theta. What would this be? This would also be capital X sin theta. This entire length would be small y. Yes or no? This entire length, PQ would be small y, right? PQ would be small y. Small y, and that's going to be this length, which is capital X sin theta, plus capital Y cos theta. Right? Now, what is this length? Y sin theta. Yes or no? Capital Y sin theta. Is this length capital Y sin theta? RS? So this length will also be capital Y sin theta. Right? Now, what is this length? This length is capital X. This length OS is capital X. So this length is going to be capital X cos theta. This length is going to be capital X cos theta. Now, do you realize OQ would be small x? OQ would be small x, yes or no? OQ would be small x. Which is going to be capital X cos theta minus capital Y sin theta. Capital OQ is, which is small x, x coordinate in the new old system, is going to be capital X cos theta minus capital Y sin theta. Yes or no? Right? Which leads us to the complete transformation of from small xy to capital XY. Small x, that means x coordinate in the old system. This is x coordinate in the old system. Capital X and capital Y are coordinates in the new system, which is obtained by rotating by an angle theta. Theta would be looked upon as positive if rotated counterclockwise, theta negative if rotated clockwise, right? So there is no loss of generality. So small x is capital X cos theta minus capital Y sin theta, that's small x, and small y is capital X sin theta plus capital Y cos theta. This is the transformation from xy to capital XY. Yes or no? Got to remember this. From small xy to capital XY, this is the transformation. If the rotation of the coordinate axis takes by an angle theta, if the coordinate axes are rotated by 30 degrees clockwise, then theta would be minus pi by 6. If 30 degrees anti-clockwise, theta would be plus pi by 6. Right? Theta would have to be plugged in with its appropriate signs, taking counterclockwise positive and clockwise negative as is customary. Now, say if they've in the old system, suppose the equation of a line is 3x plus y plus 2 equal to 0 is the equation of a line in the old system, small x, small y, right? And the rotation, say, takes place by an angle theta equal to pi by 3. I rotate the coordinate axis counterclockwise by an angle pi by 3. Then in the new system, capital X, capital Y, I want to find the equation of the line in the new system. So what I do is small x then can be converted into capital X, capital Y, would be capital X cos 60 degrees half minus capital Y sin 60 degrees, which is root 3 by 2. Small y would be capital X sin 60, which is root 3 by 2, plus capital Y cos 60 half. So replace this small x by x by 2 minus y root 3 by 2, small y by capital X root 3 by 2, y by 2, to get the equation of the line in the new system. So 3 times small x is capital X by 2 minus y root 3 by 2 is, right? Small x is this in terms of capital X, capital Y, and small y is this, which is x root 3 by 2 plus y by 2 plus 2 equal to 0. You can simplify. This will give you the equation of the line in the rotated coordinate system. Yes or no? So this bit of transformation you must understand. All's fair, right?